much for having me, and thank you very much to Rob for giving me the thumbs up to let me know it's my time to talk, because maybe I wouldn't have known. But it's an honor to be here, and it's been great to just take in this conference. There's been so many great speakers talking about ME-CFS, and today I just wanted to talk a little bit about some of the things that we've been doing from a research perspective to think about how long COVID has taught us some things about the field of infection-associated chronic illness, and also talk about some of the treatments that we're thinking about, some of the treatments that we're researching that we think are relevant across the board to many different infection-associated chronic illnesses. So the first thing that I want to do is just talk about some of the research that has emerged quickly that has allowed us to just to think about infection-associated chronic illnesses and why the symptoms that people are getting, why people might be getting the symptoms that they're getting, what's behind it, what's driving it. And there was a paper in 2023 that really looked at why people with long COVID get symptoms. And some of the most common reasons for this are listed in this figure. You know, talking about immune dysregulation, so not just the persistence of pathogens or the reactivation of pathogens, but also the fact that the immune system gets somehow worse at fighting off pathogens seems to be a problem. We see dysbiosis in the gut, and also other gut issues like small intestinal bacterial overgrowth, so all sorts of gut issues. We see autoimmunity, which I think Carmen's done a really good job of detailing. We see blood clotting and endothelial problems. And then we see central nervous system and peripheral nervous system dysfunction. And all of these things can be happening together. And in some patients, some of these things can be happening in isolation. And our experience so far has been that the trick to successfully treating and helping people to manage symptoms is to understand which of these drivers are relevant to the person in front of you, and then start to recommend treatments from there. But I really want to point out that there is now so much hard evidence for all of these drivers. I'm going to start with viral persistence as an example. In 2023, we published this paper in Nature Immunology that talked about all of the different ways where good quality trials have been published, showing without a shadow of a doubt that in a percentage of people with long COVID, SARS-CoV-2 is persisting in their bodies. Now, that could be parts of the virus that are being found, or that can be live replicating virus that is being found in animal models. But regardless, we're seeing this ability of the virus to persist in the bodies of people. So it gives us an indication that at least in a percentage of individuals with infection-associated chronic illnesses, pathogens can persist, and that can be a driver of their symptoms. I often get asked the question, why can't we see it in blood testing? If these, surely it should be easy to see, right, that these pathogens are persisting. The answer to this is, once a pathogen starts to persist in our bodies, it gets out of the bloodstream pretty quickly, and it starts to hide in our tissues. It starts to hide in our nervous tissue, our muscle, our lymph nodes. You know, these are the places, we call them immune privilege sites. These are the places where these pathogens will hide out, because the bloodstream is not a good place for them to hide, because that's where the immune system can find them and target them. So if they are persisting, they're probably not persisting in blood. So we need to go beyond blood testing to find them if we're interested in finding them. In 2023, we also published a paper with Akiko Iwasaki's team showing here that herpes viruses and Epstein-Barr virus were persisting in the bodies of people with long COVID, compared with healthy controls and convalescent controls, which were people who had recovered from COVID with no further symptoms. This is something that has been seen in ME-CFS as well, this reactivation of latent viruses. We've also started to see a whole bunch of literature emerging showing that SARS-CoV-2, beyond herpes viruses, can cause the reactivation of many viruses. So, what this is teaching us about infection-associated chronic illnesses is there are certain infections that can infect our body, and a percentage of the population won't fully recover. And once they don't fully recover, these pathogens seem to have this ability to weaken our immune system and make us more susceptible to other infections, as well as make us more susceptible to infections reactivating. So the reason I'm saying all of this is, which I'll get to at the end, is that if we take this literature in context, there's room to think about interventions to sort of target these problems that we're seeing. Again, I'm not going to spend too much time on this because Rob will tell us all about his wonderful work, but we are, again, more and more, we're seeing harder and harder evidence that it is metabolic dysfunction, not deconditioning, that drives post-exertional malaise. Again, this is hard evidence. This isn't, some sort of hand-wavy stuff that we could blame on something else. This is hard evidence to suggest that the problem is metabolic, the problem is physiological, and telling somebody to exercise more or, think their way out of the problem isn't going to work, and in fact, it's going to do harm. We're also seeing hormonal dysfunction in people with long COVID. So this was from our paper in 2023 where we showed viral reactivation. We also showed that folks with long COVID happen to have low morning cortisol levels. All of these findings, by the way, when I say people with long COVID, it's really a likelihood. They are more likely to show low morning cortisol levels. Some people with long COVID don't have these cortisol levels, but we're starting to see this in a percentage of people with long COVID, enough to make the findings significant statistically. And cortisol is a really interesting hormone because it does a lot of different things, and it cycles through the day. And so the significance of the low morning cortisol is the thing that wakes us up in the morning. So if your morning cortisol levels are low, that is going to mean that you have a lot of trouble waking up. That is going to mean that you have a lot of trouble actually, coming into the day with a high state of arousal and being able to actually do things in the morning. And so finding of low morning cortisol, I think, is very relevant to fatigue and post-exertional malaise. In addition to that hormonal finding, we also saw that folks with long COVID have certain symptoms that split out by sex. So what we saw here, and in this picture, what we see are the red symptoms are male predominant, and the blue symptoms are female predominant, just to switch things up a little bit. But, so what you can see is there are certainly symptoms that are common to both sexes, but there are also symptoms that are less frequent in men and more frequent in women. And when we really dug into this and tried to understand what was going on, what we started to see was that these symptom differences were directly related to sex hormone levels. So in women, what we saw was that women with long COVID had significantly lower testosterone levels compared to healthy controls who did not have long COVID. And in men, we saw that men with long COVID had lower estradiol levels than men who were healthy controls. And what's interesting about estradiol is that in men, estradiol is a hormone that is only made by converting testosterone. So probably, we're doing more data, we're doing more experiments to figure this out, but probably what this tells us is that across the board in men and women, we're just seeing lower testosterone levels. So testosterone is being depleted. And what we could also see in this particular study, which we've pre-printed, but it's still in review, is that the lower the men's estradiol levels or the lower the women's testosterone levels, the worse severity symptoms that they were reporting. So there was a direct correlation between those hormone levels and these symptoms. So this opens a door for hormonal therapies as symptom management techniques. We've also published a lot of work showing that blood vessels can get affected by long COVID. So we see the formation of small clots, fibrin amyloid microclots, which have been described by Ricia Pretorius's team, and we have replicated those findings in our lab. And we also see just general inflammation of the blood vessels. So this is a really interesting finding, and it also starts to explain why people can have symptoms that sort of distribute across their entire body that affect every single organ system, because when you start to have systemic issues with blood flow and systemic issues with blood vessel function, that's where you can have symptoms that move around the body and seem to, not follow any rhyme or reason. And so we find this a very, interesting and feasible theory to chase. And again, there are ways that we can test for this in patients. And if we see dysfunction in the blood vessels, then we can start to treat. I also want to point out that we've seen from this work that even mild infections can lead to neurological changes associated with central nervous system damage. So this was work that we published in 2022 in Cell, where we showed that if we infected mice with very, very mild SARS-CoV-2, they produced chemicals in their bodies, inflammatory chemicals that attacked the nervous system. When we saw that, and we saw that these mice actually experienced reductions in cognition, they got less good at navigating through mazes and things like that, we saw that they were producing a couple of chemicals that were associated with their loss of cognition. When we looked in people with long COVID who were reporting cognitive issues, we saw exactly those same chemicals, CCL1 and CCL11, which are chemicals called chemokines that were elevated in people who had cognitive loss and long COVID. We've also shown that we can take antibodies from people with long COVID, purify those antibodies, inject those antibodies into mice, and when we do that, the mice actually get sick. So we were able to show this in a preprint that was led by the wonderful Kayla Saar over there in the corner. And we did this for a number of different symptoms, but I'll just show you one slide because we've got limited time together, but this was just one slide in looking at pain symptoms in the animals that received the antibodies from people with long COVID. And not only did we see that receiving antibodies from people with long COVID could cause pain in the mice, but we also saw that it only caused pain in this group. And this is a group of people who had long COVID and also new onset pain. So the group that had long COVID without new onset pain did not cause pain in the mice. So not only can we transfer symptoms across by transferring antibodies, we can also, the symptoms that the people are having, we can start to match up to the symptoms that the mice are having. So this is starting to get to really clear evidence that what we're seeing in a subset of people is autoimmunity, and that this can be targeted with medications. And you've already heard some wonderful talks about this. And we would love to, and we do plan to replicate these findings in ME-CFS as well. We've just been collecting that data as we speak, so these replication studies are on the way. And when I say ME-CFS in this particular context, I mean people who were diagnosed with ME-CFS prior to 2020. So all of that is to say that we have a really complex process happening, and what we really need to take away from this is the idea that many of these drivers can be happening, or just one of these drivers can be happening, and over time the contributions of these drivers can change a little bit. So to that end, as we think about therapies, I really think it's very important that as researchers, as well as patients who are exploring therapies, we really try to work out what's happening, again, to the person in front of you. Like try to understand what drivers are responsible for what symptoms. And to that end, I just want to share a few quick thoughts about what we can do about these things and sort of treatments on the horizon. One of the things that I do want to share is something that is very, very simple but can be done right away is using smartphone technology for symptom tracking. We have these 2 papers that are currently under review. One has been accepted into Nature Digital Medicine and one is still under review. It's the largest study of its kind. It included 4,200 patients. 40% of those patients were people with ME-CFS, 30% were people with long COVID, 20% had both, and 10% were other infection-associated chronic illnesses. And in this study, what we showed was by using the app to drive their pacing, so using the app to do activity monitoring and sort of help manage their energy levels, 77% reported improved symptoms, 85% reported that they felt more in control of their illness, and 94% reported improvements in their ability to pace. In addition, something that was really cool was that the app comes along with a wearable, and by using the physiologic data coming from the wearable, we're now at a point where we can actually predict a crash within a couple of days of it arriving with somewhere in the neighborhood of 80 to 90% accuracy using our machine learning algorithms. And that technology is getting better and better. So not only can just using smartphone-based apps improve your ability to pace by using your own personal data to improve your own personal understanding of what's going on, we hope we're going to get to a point where we can use physiology to say, hey, a crash is coming. It might be important for you to, get your home ready, lay down, rest, etc., and that will shorten the duration of the crash. What we're actually doing with this company next is we're also going to be looking at the role of weather and weather fluctuations on symptoms in ME-CFS, long COVID, and see if we can use weather reports to predict symptoms as well, which I think would be really important moving forward. And so this is my last slide. I know I'm going a little bit over time, but I just this is intended as a very hopeful slide. So all of those drivers that we were talking about before, there are so many drugs right now that are either have good clinical data behind them, or we're in the process of getting clinical trials on the go. Mm-hmm. So I really just want to drive home the fact that we have a lot of options. As we understand the physiology more and more, there's more and more that we can be doing. And these are just single drugs. So there's also the opportunity to be combining drugs. And our team is starting our first combination therapy trials as well. So I really just, if you take anything home from this particular talk, it's that, long COVID has really accelerated the speed of a lot of research into the area. We're learning a lot about the pathobiology of infection-associated chronic illnesses and energy-limiting conditions. And there's a lot of work for us to do with really hopeful clinical trial targets. So I'll just thank everyone on my team for all the work, and we'll stop there. Thank you.